everyone, my name is Ecenaz Bağlan and I'm a freshman student in Electrical and Electronics Engineering in Bilkent University. Today I will present my Physics 101 lab project. The name of the experiment is the effect of the release angle on the time period of a simple pendulum. The aim of this experiment is to observe how the release angle affects the time period of a simple pendulum. According to small angle approximation, the time period of a simple pendulum nearly remains unchanged for small angular displacements. However, for larger angles, deviations can occur because the sine function becomes nonlinear in the restoring force. The equipment needed for this experiment is a protractor, a stopwatch, a string which is 0.37 meters long, a calculator, a ruler, and a metal disc, and also a stand for suspension. First, I set up a pendulum with a 0.37 length of string. Then I pull the metal disc to an angle 5 degrees with a protractor. Then I measured the total time taken for 20 oscillations using a stopwatch and noted these measurements. By repeating these steps 3 times for all angles, respectively 5, 10, 15, 30, and 45, random errors can be minimized. Here you can see the data I have collected and also the mean period and standard deviations for each angle. In conclusion, this experiment examined how the release angle influences the period of a simple pendulum and evaluated the validity of the small angle approximation. For small angles, 5, 10, and 15 degrees, the measured periods were very close to the theoretical value, which is 24.4 seconds, with percentage differences below 2%, confirming the accuracy of the theoretical formula in this range. However, at larger angles, 30 and 45 degrees, the measured periods increased and deviated more from the theoretical value, showing differences up to 5.66%, and this occurs because the restoring force becomes nonlinear at larger angles, causing the simple pendulum formula to lose accuracy. Also, I calculated standard deviations for all angles to see whether the collected data was consistent and reliable or not, despite minor uncertainties such as air resistance, human reaction time error, and all of the standard deviations came out low, which indicated that the data was precise. Overall, the results support the small angle approximation and show that theoretical value accurately predicts the period only for small angular displacements. Thank you for listening.